In this problem, we are given a bullet and a cart, and we're to find the energy loss when this bullet impacts the cart. And to do that, we'll use linear momentum equations as well as the energy equation. And once we find the energy loss, we'll also find the percent loss. So let's get started. The mass of B is initially going at V naught, and that V naught is the 600 meters per second. And at that point, the cart is resting, so that is going to be 0. And then when they connect, the mass will be MC plus MB, and that is going to be V final. And once we find V final, we can use that in the energy equation to find the total energy loss. So solving for V final, you get that it is 0.075 kilograms times the 600 meters per second all over the 50 kilograms plus the 0.075 kilograms. And that boils down to 0.899 meters per second. So we know immediately that there's going to be a lot of energy loss because its change in velocity is so great. But let us keep going and prove that. There's no movement vertically or horizontally from the cart's position, so we know that mgh is equal to 0. And we're going to find the absolute value for the change, and we're going to use kinetic energy because we have the velocities 1 minus 2, although it doesn't really matter because we're looking for that magnitude in positive terms. So delta E is equal to 1/2 mb v naught squared minus 1/2 mc plus mb times v final squared. And we just solved for that v final. So we get that it is 0.075 times 600 squared minus 1/2 of 50.075 times 0.899 squared. So the total energy lost is 13,480 joules, which is quite a bit. And that is the answer for delta E. But now we need to find the percent loss, and that is the variable N. And that will be delta E over kinetic energy of 1. And we solved for that kinetic energy of 1, and that was 20.2 times 100 times the 13,480, and that is 99.9% loss, which is quite a bit. So we're given a bullet and a cart. We're given information about the velocity of the bullet initially. Once we find the final velocity of where after that impact, then we can use that final velocity in the energy equation using the kinetic energy portion of it to solve for the change in energy and therefore solve for the percentage.